Hi everyone, welcome back to my channel. Today we are going to flatten a binary tree to linked list. It's a medium level problem, but let me I will show you the approach and the complexities, and it will be very easy for you guys. Okay, so first let me read the problem statement. So given the root of the binary tree, flatten the tree of the link, flatten the tree into a linked list. So linked list should be the same of tree node class and right child pointer, next pointer. The list to the left child pointer is always null. Okay, left child pointer will be always null. Linked list will be the same as pre or traversal binary tree. Okay, so what we're doing here? So let me quickly draw this thing. Okay, 2D shape. Okay. Draw according to this. Mm, Ten. Just wait like 3, 4, 8, 9, 5, 9, 8, 6. I think. Okay, so like I have drawn the tree. Now let me show you how what we are trying to do here. Okay, so okay. So first we need to convert it to a linked list, or like all the left pointer should be null and it should only point to right pointer side. So what is the approach? So, okay, before that, we need to know the Morris traversal. So, what is Morris traversal? So, in Morris traversal, so that is a simple like other traversal, like level order, pre-order, in-order traversal. But the main difference is the here we don't use any stack queue. We don't use any data structure for that. So that like the space complexity goes to O of 1 in Morris traversal. Anyway, I will post another video on Morris traversal, but today in this video, I will show you this problem. But the approach we are going to use, that is Morris traversal. So what we are going to do here? So first we'll take it as a current node. Okay, this is the current node, and now we are going to find first. We are going to find the predecessor of the current node. So what is predecessor? So in predecessor, simply remember that if we need to find a predecessor of any node, go one left, okay, and keep going to the right until it gets to it gets null. Okay, so we go one step left, that is 3, and we're going to check until it gets null. So after it is null, so this is the predecessor. Okay, now once you find the predecessor, we need to connect node. Why? Because like what is the output they need? What is the output they need? Like one, can't draw this now. 1 minute. If I show you this, so as you can see, uh, like this 4 is pointing to 5. See, the 4 is pointing to 5, and there is no connection between 1 and 5 because the like whole left part goes to the right. Okay, so like 2 is pointing to the right of node 1. You're getting my point. See, currently 1 is pointing to right, the right pointer of 1 is pointing to 5, but we are going to change it to uh, as that 1 should point to 2 from the right pointer, and left pointer will be null. So for that, as you can see, 4 is pointing to 5. So here we're going to make a connection. This okay. This is a temporary connection from. So the connection will be like this node to this node, and then there will be no right pointer of the current node, so it should point this node. This is second step, and last is we are going to cut this left pointer. We will mark it as null. So what will be the final look? So 10 will point to this 3. Okay, 3. Then we are going to do the same for this subtree. Right, for now I'm showing this, and 5 will be 6, then 8. This will be the structure. Okay. Now let me do the coding. It will be more clear when I complete it. Okay. So first let me check if root equals to null. If root is equals to null, then just return not null. Then we are going to mark it as like the root node will be current node. So let me put that data type is current. Now we are going to run a while loop. So until how long this while loop should run? Until the current. So okay. It's true now. So if the current is not null, then this while loop should go. So currently, what is the current node? So just remember I showed you the structure. Okay. So now current. So we have marked this as a current. Okay. This current. Now current. Now first step we are going to find the predecessor. So this is step 1. Find predecessor. So to finding predecessor, we are naming it as pre, and so remember first step is go one left. So current of left. So this is now pre. Now keep going to right until you get to see a null. So there will be a while loop. So pre if pre of right. Not equals to null. So just go pre equals to pre of right. Okay. So in first iteration, it has reached to the leaf node, the final node. Now, as you can see, it can't go further of this because there is null. Okay. Now, time to perform our step. This is step 1, finding predecessor. Now, step 2. Now, in step 2, we are making the connection. Step 2. In step 2, we are making connection between these two nodes because, as you can see, this like whole left part is going to get nulled. So we are going to transfer this whole part to right. But according to our statement, we can see this 4 is directly connected to 5. 4 5. So we're going to make a connection between this. Okay, now this, so this is 4 and this is 5. So we have now pre of right equals to current of right. This step 2. Why? Because this pre of right is pointing to this pre of right pointing to current of right. Okay, this current of right. Now this connection is established. Okay, now we need to drop this connection, right? So for that, what do we need? We need to make the connection of current of right should point current of left, right? This is current of right, it should point current of left, right? Because that's the only way to get this, the whole say, right, left subtree part to right. And yeah, so current of right equals to current of left. Okay, this is step 3. This is called, we can mark this step 3. Step 3. Now once the connection is established, we need to drop this, because like both the pointer are now pointing to left, because that can't happen, right? So we need to make this to null. This is null, so left of 10 should point to null. Step 4. So current of left equals to null. Okay, now outside this loop, so we can go to next, current equals to current of right. That's all. Yeah, so why this is out of okay, okay. We can put another, if else condition, like if current of left exists, then perform this part, then perform this. Yeah, else perform just go current of right. So it means like if it is already like this. Suppose this is only this. So if we were at this node, if initially when we're at this node, if there is no left value, then why should you perform this? So first we're checking if there is any left subtree or left child exist or not, then perform this, or just move on to current of right. So current of right. So now run it. Let's save. So okay, so okay, yeah, that's cool. So as you can see, we haven't taken any extra data structure. So time complexity of O of n and space is O of 1. Thank you for watching.